Hello everyone. So we are here with our second test series which is on acids and bases. That is very limited and scoring topic for CSIR net. So first of all you have to try every question with yourself, only then you should watch the solution. So let's start with our first question. The reaction between SbF5 and two equivalents of HF leads to the formation of. So you just simply have to do the reaction between SbF5 and two equivalents of HF. So just pause the video and do it by yourself. So now comes to the solution. Here we have SbF5 plus HF. So SbF5 we know is a very good Lewis acid. So it accepts F negative from HF compound and gives out SbF6 negative. And here we have H positive. Now this H positive react with the second equivalent of HF and gives H2F positive. So these two are very equivalent to our answer, that answer number D. So here we have answer, that is answer number D. That is answer number D. So this is our correct answer. Now comes to the next question. These questions are very simple, as you can do easily within fewer seconds. So second question is the compound that give basic solution in HF is. So we have to tell the compound which give basic solution in HF. So generally the Lewis acid react with HF to give acidic solution. Otherwise all other compounds give basic solution with HF because it undergoes self ionization to give F2 negative and H2F positive. So we generally have to try it to make HF2 negative. So here we have in first option is ASF5, second is PF5, third is BF3. These all three we know are Lewis acids. So Lewis acids react as acids in HF. So they do not give basic solution. So answer should be answer number D. Let's see here. In first three options, these are Lewis acids. So it easily accept F negative ion from the HF and become like ASF6, BF4 negative, PF6 negative. Only the BRF3, that is not Lewis acid because it has its complete octet. So it give basic solution with HF. So correct answer is answer number D. Now comes to the third question. The compound that will behave as an acid in H2SO4. So you just simply have to tell the compound which gives acidic solution in H2SO4. So for this we have a series. Series is here. This is the series in decreasing order of acidic character. So Hi has higher acidic character than HClO4, HBr, HCl, H2SO4, HNO3. So this is the correct series for acidic character. So here you can easily see in our question we have to tell the compound which will behave as an acid in H2SO4. So first option is CH3CO4. We know CH3CO4 is a very weak acid, so it will not behave as an acid in H2SO4. Second is HClO4. Third is HNO3. Fourth is H2O. H2O is also a weak acid, so it also will not behave as an acid. So we just simply have to check from B and C. So comes here. Here HClO4 and this is H2SO4 and this is HNO3. So as we are easily detect from the series that HClO4 has higher acidic character as compared to H2SO4. So simply it will behave as an acid in H2SO4. So our correct answer is HClO4 because it has higher acidic character than H2SO4. So it will behave as an acid in H2SO4. So these questions are very simple as I already told you. So next come with the next question. Fourth question, in BrF3 as a solvent, SnF4 and Kf behave as. We just simply have to say that if BrF3 is a solvent, then SnF4 and Kf behave as acids or bases. So how can you solve this? Just simply take SnF4 plus BrF3 and Kf plus BrF3. So SnF4 we know is a Lewis acid. So it is just simply try to accept F negative from BrF3. So it accept F negative and become SnF5 negative. So it and remaining BrF3 becomes BrF2 positive. And here simply in the case of Kf, it donate F negative ion, so becomes BrF3 as a BrF negative. So the compound which gives solvent cation is acidic, and which gives solvent anion is basic. So firstly SN4 gives solvent cation, this is solvent cation, and this is solvent anion. So in the first case we have it is behave as an acid, and this one behave as a base. So our correct answer is answer number C, that is acid and base, because SnF4 gives solvent cation and KF gives solvent anion. So it will be respectively behave as an acids and bases. So here with our next question, in the reaction between A and B, these are two reactions are given, water behaves as. So you have to tell that the behavior of water in these two reactions. For this type of questions we have a simple explanation, that is you have these energy level diagrams. Here we have H2O, this is CaCl, Mg2 positive F2. You just have to learn with a trick that kya kal mein fark. So just you simply learn it by this trick. So here this is H2O, HOMO and LUMO for H2O. You have to check simply with respect to H2O. This is for Ca, this is for Cl negative, this is for Mg2 positive, and this is for F2. So first here we have A, B, C, D and E. Simply we have to recognize the relationship between all these with respect to water. So firstly between A and B, as we know the gap between A and B is very high. So first case, comparison between A and B. So gap between A and B is very high. So it is not possible for them to form adduct. So adduct formation is not possible here. You can also read out the information given on the page. But electron transfer is possible. So as calcium have higher energy, so it react as HOMO. Its HOMO gives electron. It becomes Ca2 positive plus 2 electron. Similarly H2O here accept electron from this Ca. It accept electron from this Ca and comes out with H2O plus Ca gives Ca2 positive plus 2H2 plus 2OH negative. So here we simply tell that here H2O behave as an oxidant and Ca behave as an reductant, because reductant is that which reduce others and oxidize itself. So here Ca oxidize itself by donating electron, so it is reductant, and H2O is oxidant. Now come to the second case. So one important thing is also here that Ca is not a Lewis base, it is reductant, and H2O is not a Lewis acid, it is oxidant, because electrons are sharing, no adduct formation, because due to high energy gap no adduct formation here is takes place. Now case second is between comparison between A and C. So we have A is water and C is this Cl negative. So you can easily see there is very less energy gap between these two, A and C. So adduct formation is possible here. So just look here, this is H2O and Cl negative. Here adduct formation takes place, Cl, H2O and negative. So as you see, energy of Cl is little bit higher than that of H2O. So Cl here donate electrons and H2O accept electron. As Cl negative donate electrons, so it will behave as Lewis base, and H2O will behave as Lewis acid. Similarly, in the case of A and D, there is also very less energy gap between this, but here H2O is on the upper level. So H2O here donate electron and form adduct formation with Mg2 positive. So H2O here is Lewis base and Mg2 positive is Lewis acid. And we have last case as A and E. There is also very high energy gap. So these are also not behave like Lewis acids and bases. This will behave as like oxidant and reductant. So here H2O donate electron. So it oxidizes itself and basically behave as a reductant, and F2 behave as an oxidant. So here you can simply read out the information given on the page. As a comparison between A and B, much lower energy than water. So water donate electrons here and oxidize itself and behave as a reductant, and F2 behave as oxidant. This is very important and repetitive questions are put on these theories. So here now come to our question. This is a question that in the reaction between A and B, first reaction is an H2O plus Cl negative. It gives adduct formation. So here we see this is H2O and this is Cl negative. They form adduct, and here Cl negative behave as Lewis base because it donate electrons, so it will behave as Lewis base. Just 1 second. But here we have to tell the behavior of water. So in the first case, Cl negative behave as Lewis base and water behave as Lewis acids. So we have acids in the first case in two cases, here and here. For the second we have Mg2 positive, and with Mg2 positive H2O behave as Lewis base. So our correct answer will be answer number B, acids and base. In the first reaction water behave as Lewis acid, and in the second reaction water behave as Lewis base. Now come to the next question, sixth question, that is very similar as we do last question. Water plays different roles in the following reaction. We have to tell the different roles played by water in the following reaction. As first case is with Ca. So we know with the Ca water behave as like oxidant. So answer will be like first or second. Water will behave as like oxidant, and in the second with Cl water behave as like Lewis acid. With Mg2 positive water behave like base, and in last F2 water behave like reductant. So correct answer will be answer number 1. So this theory is very important as we do read out the whole theory, because many of the questions put out repeatedly in the CSIR net exam on this topic. So now we have question number 7. Two reactions are given, reaction A and reaction B. You have to tell these are the examples of disproportionation and solvation. So basically disproportionation is a reaction in which oxidation and reduction take place in the same reaction, and solvation is where breaking of solvent doesn't take place, and in solvolysis we have breakage of solvent break in solvolysis, but in solvation solvent do not break, and disproportionation where oxidation and reduction takes place in same reaction. So just simply do its solution. We have first reaction as Cl2 to H2O gives HOCl H3O positive and Cl negative. Simply अगर हम इसमें देखें तो क्या है कि Cl2 have zero oxidation state, and if we come on the right side, here we have Cl in +1 oxidation state and also in +-1 oxidation state. So here oxidation and reduction takes place in a one step reaction. Also here we have solvent as water. This is solvent as water, and here water does not remain same, it breaks in OH and H2 H3O positive. So here solvolysis takes place. Come back to the question. Here also solvolysis and disproportionation reaction takes place. If we talk about the reaction number B, then here also the same case, Cl2 break into Cl positive and Cl negative. This is disproportionation, and NH3 here is solvent. Solvent also breaks to undergo self ionization to give NH2 negative and NH4 positive. So these two are examples of solvolysis and disproportionation reaction. Correct answer is answer number D, solvolysis and as well as disproportionation. Now 8th question is, among SO2OHF, CH3COOH, LiF and H2O, the compound which behave as base in liquid HF is. So हमें बताना है कि कौन सा कंपाउंड इनमें से एक बेस की तरह बिहेव करेगा इन लिक्विड HF. So in liquid HF all compounds generally behave as base because we have to want HF2 negative. So and it is only become when the given compound will behave as base and HF behave as acids, because HF2 negative has very strong H bonding. So generally we try to make HF2 negative. So generally all the compounds will behave as base in HF. Simply how they can behave as base: take example of CH3COOH. If we react it with HF, then it accept H positive from HF and behave as acid, behave as base, because base accept H positive and acids donate H positive. So basically it accept and behave as base, and here we comes out with F negative. This F negative now again react with HF to give HF2 negative. So here similarly you can do it by all the three given in the question, and we come out with the answer that all of the three behave as base in liquid HF. Next, 9th question is, the cations formed upon dissolving SnF4 and AuF3 in liquid BrF3 separately respectively are. कि जब हम इन दोनों का रिएक्शन करवाएंगे BrF3 के साथ तो कौन कौन से cations हमें देखने को मिलेंगे. लेट्स कम टू द सॉल्यूशन. So first of all, SnF4 plus BrF3. SnF4 behave as Lewis acid, so it simply accept electron from BrF3. So आप क्या देख रहे हैं यहाँ पे कि एक ही थ्योरी है जो बार बार रिपीट होती जा रही है हर एक क्वेश्चन में. So you can simply solve all the questions of acids and base by applying these 2 or 3 theories again and again. So here SnF4 behave as an Lewis acid and accept F negative from BrF3, and it comes out with BrF2 positive cation. Similarly, AuF3 accept F negative from BrF3 and comes with BrF2 positive anion. So our answer is answer number C. Only BrF2 positive is remain cation after undergoing these two reactions. Now come with our last question. Consider the following reaction. Hg2 positive plus X negative give HgX. The stability constant for X is equal to FCl. Follow the order. So this question is very simple based on the soft and hard acid concept. So Hg2 positive is soft in nature, and among FCl and Br, if we talk, Br has soft character. So bonding of Hg and Br is very high and it has high stability constant. So answer is answer number A. That is correct answer. FCl and Br based on hard and soft acid concept. Done for today. Hope you will enjoy the video. Thank you so much for watching.